Why are rare earth elements so important in world technology wars? The tension between the new US administration and Ukraine, EU, England and Canada is not only economic and political, but also military and technological. If you are wondering about the effects of these strategic minerals on world peace and trade, let's continue. First, let's look at the properties of rare earth elements and where they are used. Then let's examine the current and potential risks of economic and armed war that will affect the whole world. Rare earth elements are of critical importance in many areas of modern technology, thanks to their unique physical and chemical properties. They include scandium and yttrium, which are the 21st and 39th elements of the periodic table, as well as lanthanides with atomic numbers 57 to 71. Rare earth elements are generally soft and easily processed, and they show reactive properties at high temperatures. Their colors range from iron gray to silver white, and their melting temperatures range from 798 to 1663 degrees Celsius. They can react slowly with water to release hydrogen gas. They exhibit paramagnetic properties. The unique properties of these elements have made them the cornerstones of modern technology, while the security of their supply has also become a global strategic issue. The origin of the lanthanum element comes from the Greek word lanthanine, meaning hidden. It is an abundant element, but its extraction and processing are quite difficult. It strengthens metal alloys, requiring high performance in aviation. It improves the glass quality in cameras, telescopes, and night vision goggles. It is found in nickel metal hydride, NiMH, batteries used in hybrid vehicles. It is used as a catalyst in oil refineries to increase fuel efficiency. Lanthanum carbonate is also used in the treatment of kidney diseases. Cerium origin comes from Ceres, the goddess of agriculture and nutrition in Roman mythology. It is named after the asteroid dwarf planet named Ceres, discovered in 1801. It is the most abundant of the rare earth elements and is very valuable to industry due to its wide range of uses. Cerium-based materials are used in green energy hydrogen production and fuel cells. It is widely used in catalytic converters that clean exhaust gases in automobiles. It improves the quality of camera lenses and telescope glasses. Praseodymium compounds are green in color and take their name from the Greek prasios didymos, meaning green twin. They are found in electric vehicle engines, wind turbines, and hard disks. They are added to the structure of superalloys used in jet engines and increase heat resistance. They are used as electrode materials in batteries operating at high temperatures. They play a role in hydrogen storage systems. Since neodymium was discovered with praseodymium, the Greek word neos didymos means new twin. Neodymium is one of the cornerstones of modern technology and is an indispensable element for green energy, electronics, and the defense industry. Neodymium iron boron, NdFeB. Magnets are one of the strongest types of magnets in the world. Electric vehicle engines and wind turbines cannot operate without neodymium magnets. It is used in jet engines, guided missiles, and military optical systems. Neodymium lasers are used in medicine, industry, and military fields. The name Promethium comes from Prometheus, the god who brought fire in Greek mythology. This name was given because it is used in nuclear energy production. It is not found in pure form in nature. It is usually obtained in limited amounts as a result of the decay of uranium and plutonium in nuclear reactors. Although it is radioactive, it does not emit dangerous gamma rays, so it provides safe use in controlled areas. It is used as a low-power energy source in space probes, satellites, and deep-sea equipment. The name samarium comes from the mineral called samarskite, which is dedicated to the Russian mining engineer Vasily Samarsky-Baikovets. Samarium has higher temperature stability compared to neodymium magnets. It is preferred in electric motors, jet engines, spacecraft, and radar systems. It is one of the elements that provide nuclear reactor safety and control. It is found in laser technologies and medical devices. Europium is named after the continent of Europe. Europa is the daughter of the Phoenician king Agenor. Europium is one of the rare earth elements with the strongest light-emitting capacity. It provides color regulation and light production in digital screens, televisions, computer monitors, and LEDs. It is included in documents such as credit cards and identity cards to provide unforgeable security. It plays a critical role with its neutron-absorbing feature to ensure the efficient operation of nuclear reactors. It helps in cancer diagnosis and treatment processes. Gadolinium comes from the name of the Finnish chemist Johann Gadolin. Gadolinium has done important work on rare earth elements. Gadolinium is used in electronics, high-power magnets, and magnetic storage areas. It is critical for nuclear safety and control. It is used in Mr. Medical imaging to obtain clearer and more detailed images. Terbium is obtained from a mine in Ytterby, Sweden. Terbium compounds are used to produce high-performance magnets due to their enhanced magnetic properties. It is used in hard disk drives, magnetic storage areas, and magnetic sensors. It plays a critical role in LED displays for high resolution. Dysprosium is an element that is very difficult to isolate, coming from the Greek word dysprosidos, meaning hard to reach. It is of strategic importance due to its rarity and high demand. Dysprosium-neodymium alloys are used in the production of powerful magnets. These magnets are found in wind turbines, electric vehicle motors, and hard drives. Dysprosium compounds are found in lasers and high-intensity lighting systems. It is used in sound systems and sonar technologies. It is used in nuclear reactors and control rods due to its high neutron absorption capacity. Holmium was discovered in Sweden and named after the capital Stockholm. Holmium provides higher magnetic performance in neodymium-based magnets. It is used in nuclear reactor control rods due to its neutron-absorbing properties. It is also used in medical fields such as MRI and laser. The name erbium also comes from the town of Ytterby in Sweden, because elements such as erbium, terbium, ytterbium are obtained from the same mine. Erbium is added as an alloying material to make other metals stronger and more resistant to corrosion. It is used to strengthen the signal in long-distance fiber optic communication. It is used in nuclear reactor control rods due to its neutron-absorbing properties. It is used in eye surgeries, skin rejuvenation, and dentistry medical fields. The name thulium comes from the ancient name Thule for Scandinavia. Swedish scientist Per Theodor Cleve discovered this element and named it after Scandinavia. Thulium is one of the rarest lanthanides. It is used in magnetic storage systems of some magnets and electronic devices. It is used in infrared laser systems in the defense industry. It is used in nuclear reactor control rods due to its neutron-absorbing properties. It provides low-dose radiation to portable X-ray devices. Ytterbium also comes from the town of Ytterby in Sweden. Ytterbium alloys increase durability similar to stainless steel and are used in some aerospace materials. It is found in semiconductor and superconductor materials and magnetic storage systems. It is used in nuclear reactor control rods due to its neutron-absorbing properties. Ytterbium-doped lasers are used in high-power cutting applications in medicine and industry. Lutetium comes from the old name of Paris, the capital of France in ancient Rome, Lutetia. French scientist Georges Urbain discovered this element and named it after Paris. It is the last element of the Lanthanide series and is one of the heaviest and least abundant rare earth metals. It is used in atomic clocks and magnetic storage systems. It is used in nuclear reactors due to its durability at high temperatures and neutron-absorbing properties. It is used as a catalyst in oil refining. Scandium was first discovered in minerals found in Sweden, and therefore takes its name from Scandinavia. It has limited areas of use due to its rarity and high production cost. High-power lasers are produced from scandium-doped materials. It is used as an additive in semiconductor production and batteries. Yttrium comes from the town of Ytterby in Sweden. It is the first element discovered here. Yttrium-based crystals are used in optical fibers. It includes heat-resistant ceramics used in jet engines and space shuttles. Its lasers are widely used in medical, industrial, and military applications. It is used in nuclear reactors due to its neutron-absorbing properties. Yttrium-based bioceramics are used in dental and bone implants. World technology wars and rare earth elements. China's control over rare earth elements is the cornerstone of its strategic influence in the global technology and defense sectors. China has become the dominant player in this market, accounting for more than 60% of global rare earth mining and 90% of processing capacity. In December 2023, it announced a ban on the export of rare earth processing technologies. By imposing export restrictions on the US and Europe, China can create crises in the technological development and defense industry supply chain at any time. The US is struggling to break China's global technological and economic dominance over rare chemical elements. The US is working to restart its once important Mountain Pass mine in California to reduce its dependence on foreign imports. The US is pressuring Russia-occupied Ukraine for access to rare earths and other strategic minerals. Russia's Tomtor deposit in the Yakutia Republic of Siberia is one of the world's largest rare earth element reserves. However, it has difficulty exploiting its potential due to limited processing capacity. Russia and China are actively seeking to secure critical mineral assets in Africa and increase competition with Western countries. They may attempt to seize critical rare earths by occupying eastern and southern Ukraine. Ukraine has one of the largest titanium reserves in Europe and is a major player in titanium sponge production worldwide. In today's world where technology and trade wars are at their peak, rare earth elements have become more important than ever for world peace.